Hi, welcome to Real Learning Center where we focus on real learning. So we are going to start a new series on solar system. So this series has got 4 or 5 videos, and each one will target basically certain understanding of solar system. Okay, so starting from the basics. So let's just look at what is there in this series. Okay, we have about 4 videos. In fact, may become 5 videos. Let's see, 4 videos. So the first one is part 1 is talking about sun, earth, and moon. Okay, so in that we are going to basically answer some questions. Okay, and then we get into eclipses. We understand the eclipses better because most of the times we think we know, but we may not know. So let's see whether we know everything about eclipses. And then we get into space travel. So we understand, we'll try to see whether we can go to moon in an aeroplane. If we can, how we can go. If we cannot, what can we do? Okay, so we'll see that in the space travel. And lastly, we will have try to understand planets. We will not go through each planet separately and try to understand that. Instead, we will try to see, we will go for a search in search of planets where we can live. Suppose if we can't live on Earth after several thousands of years, we may have to have another planet to live. So we have to start searching for that now. So let's search for those planets where we can live. Okay. So these are the set of 4 videos. We're going to work with solar system, and I will start with the first video today with part 1, sun, earth, and moon. And in this video, I'm going to basically ask and answer 3 questions. Okay. The first question is, who is at the center of solar system? Okay. Second question, which has been actually bothering the scientists for quite some time. So let's see whether we can answer that. And second question is, what causes seasons? There are lots of different kinds of misunderstandings about what causes seasons. Though in the classrooms, we by heart things and study what causes seasons. To get a real understanding of what causes seasons and the logic behind that will be interesting. Okay. So finally, we will ask a question: is moon at all rotating about its own axis or not? So, and we try to answer these 3 questions, and these 3 questions form the basis of the first video. Okay, let's start with the first question. The first question is, who is at the center? Okay, is it the earth, or is it the sun, or is it a central fire? Okay, so this question has been basically in the knowledge of people, they keep asking these questions for quite some time. Okay, so we can go back to like thousands of years, and people had this doubt: what is at the center? It's important. Now, what is at the center of the whole system, solar system? And for a long time, it was considered to be a geocentric model where Earth is at the center, and then it all changed. So let's just look at this a little bit pretty quickly to understand what is at the center of our solar system. Okay. So first question, first thing that is basically is, what are these so-called planets? Now, there is a certain definition that you must have read through, but let's say you go to the you go in the night outside and look at the sky. Okay. So when you look at the sky, so there are all so many dots. In the sky is all stars. Okay. And some of them are supposed to be planets. And when you ask people about how to differentiate stars and planets, the normal answer would be something will be twinkling, others will be not be twinkling. So you will also know that answer and go there and write there. Okay. So, but have you seen? Have you gone out and seen? Does it really twinkle? What is this twinkling? So this question is something that you need to figure out. You have to go out and see, look at the sky and figure out in the night. Okay, when there is no cloud. Okay, and you see here, long time back, like ancient Greeks, 2000, 2500, 3000 years back, Babylonians, Mayans, And our Hindus, ancient Hindus, actually, they kept studying the sky. Okay, and what they saw was, in the sky, you see so many dots. Okay, today I just saw the sky, and so many dots are there, so many stars are there, and you just watch that arrow. Okay, it's important to understand how they first of all found out these planets. So when you look at this that small dot, tomorrow actually at the same time you come back and watch the sky, same time. Okay, so it looks almost similar, but you see that tomorrow you saw that one of the dots was actually slightly displaced from its original position. Earlier it was somewhere here and then moved to a little bit further to the right. Whereas all the other dots with respect to other dots are all staying in the exact same positions. They have not actually moved anywhere. Okay. So the question that would come is, what is this slightly moving around or a wandering star? So wandering star, they called these things as wandering stars. Some of them actually wander. They don't stay where like others. Okay. So though the whole star is actually moving, whole star group is moving because of which they see daily, morning, evening, day, night, and middle of the night, they see that keeps moving. But with respect to that background, one particular star or another particular star, some of them actually started, they noticed that they were actually moving. So they called them as wandering stars. And in Greek, wandering stars actually, the word used is planets. Planets means wandering stars. Okay. So that is how the word planet came. It's a wandering star, moving around star. Okay. So there was actually, next day it moved a little bit more, like that they can see. And they found out that there are actually just about 5 such wandering stars. Out of the thousands and thousands of stars they are able to see on the sky, only 5 of them are actually wandering stars. And they named them, and they called them planets, and they named them. Okay. So they named them as basically Mercury, Venus, Venus, and then Jupiter, Saturn. Okay, these are the 4, and the Mars also, of course, 5. 5 of them they actually named. They could see, their naked eye, they could see those small dots which actually move. Okay, this they discovered how much time back? 3,000 years ago. So they were so curious then, looking at the stars. Okay. And these 5 actually you can see without the need of any telescope. So you can see, even today you can in the night when there is no cloud you can see them. Okay. So these are called planets. First 5 planets that they discovered, and they kept on looking at the sky and forming their own theories. What is there, which is going around which one, what is moving, what is not moving. Just have your theories and see whether there are evidences to support those theories. Those kinds of things. And if you look at the Babylonian astronomy, the astronomy looking at the stars and trying to understand, that was actually started long back, like 3000 Babylonia. So look at those dots, that is the Babylonia. So what were they believing in? So they were actually believing in many things. Okay, one of them is, this is basically 7th century BC, so like 2700 years ago. Okay, they actually did lots of observation, and they knew that there were actually 5 planets. Okay, and they were also knew that in fact they started this concept called as bad omens. The word bad omen, and they basically based it on astronomical phenomena. So something is here and something is there, then it is bad thing. Okay. This kind of a concept started actually first in Babylonia, in Babylonian astronomy. So they discovered actually around 5 planets they knew. Okay, and then you go into another area called as Greco-Roman astronomy, Greeks and Romans. Now you can look at where the Greeks and Romans in the place, and they also studied a lot, okay, about astronomy, and they had some interesting concepts actually. These Pythagoreans in the 5th century, Pythagoras you may be knowing. Pythagoras is one with Pythagoras theorem, rectangle, triangle, the same Pythagoras. He did a lot of astronomy also. So people who followed him are called Pythagoreans. So he actually named, he came up with a planetary theory. Okay, according to his theory, there are actually 7 planets including Moon. Okay, Sun also planet according to him. and other 5, so total 7. And he said that those planets were actually going around something, some central fire, some other fire is there, it is going around that. That is his theory. Okay, but the theory which was mostly accepted by all the Westerners, all the European and America was still not there. So European and other countries basically accepted a theory from Ptolemy. Okay, Ptolemy was the greatest astronomer. He actually came with this concept that Earth actually is at the center and everything is going around that. So it's a geocentric model, and most of the Western philosophy is based on this particular model. Okay, that Earth is at the center. Okay, it's called geocentric model. So what are the Indians doing anything at all at that time? So Indians were actually, okay, Indians did a lot of astronomy too. Okay, and Indians came up with very interesting things which we don't give too much of importance because we don't study it well enough. So if you see from the Vedic period, they are kept observing basically many stars and planets and all that. More than that, they actually came up with this Earth rotating about its own axis very early by Aryabhatta. Okay, and there is also one more important thing is there was a Kerala school of astronomy. They came up with a quite interesting task, theory, saying that all the planets, including Mars, Venus, Mercury, all of them are actually going around the sun. But the last part they messed up. They said that then sun carrying all these planets is actually going around the Earth. That is what they said. That is the Kerala school. That's quite an interesting thought, though. Okay, so but however, to actually bravely say that it is not at all the sun which is going around the Earth. Earth is not at the center. Okay, Earth is just another planet somewhere rotating around the sun. That was a very brave statement. To make that statement, the person who came was only in 16th century, 1500 something. This guy is called Nicholas Copernicus. I mean, it is basically called as a Copernican inversion. Means in your mind, it is Earth is at the center is fixed. Nobody doubts that. Everything else they make theories. But this guy actually removed that particular bias of us. He wrote one book. Basically, it's called as the De Revolution Omnibus. This is one of the first books which, scientific books which got actually printed. Printer was also invented then. So it took more than a year to just print this one book. And actually when the book came about, he kind of expired at that time. Okay, so he didn't see the circulation of the book. This book created waves. People actually just did not agree with him because it is like challenging the whole of belief system. Okay, actually, especially this guy was a Christian priest. So though he was a Christian priest, he actually came with a very revolutionary theory. Though Christians at that time did not believe in this heliocentric model. Heliocentric means sun is at the center. So if you look at it, he came up with this theory saying that forget Earth is at the center. So this is the time to say that sun is at the center. Okay, he said, if you look at the center, that is sun. Okay, and then he said that Earth is actually like any other planet going around the sun. So and he just not only made this theory, he actually supported the whole theory by proper mathematics, geometry and all that. In fact, he writes in the first page of the book, people who don't understand geometry, please don't read this book. Okay, so that kind of a very, very mathematical book. And he is considered to be the father of heliocentric theory. Okay. This happened how much? 450 years back. And some people later got support from him, like Galileo and Newton and all. Finally, that became the main theory. And according to that theory, today we believe in that theory and we say that actually planets go around the sun, and there are about 8 planets. Pluto was supposed to be one of the planets which got discarded later, and now 8 planets are there, and there are also smaller satellites which go around the planets. So these are the theories which are today prevailing. Okay. Now, after having understood this, let's now get into the slightly more details of this, and we'll now start with Earth and Sun. Okay, just 2 of them. So, and try to understand that how is the relative motion between them. So clearly see here, actually, Earth is rotating on its own axis and at the same time actually going around the So there was rotation and revolution. So that is the first step to understand solar system. What is the relation between Earth and Sun? Earth is rotating on its own axis and also going around the Sun. Now, one complete rotation of about its axis takes about 24 hours. One time to rotate around its own axis takes 24 hours. And to go around the Sun in one full round trip basically takes about 365 days and 6 hours. Not just 365 days, 365 days and 6 hours. Okay, that is the total time. Also, you can see the days and nights. How do they get cast? How are the days and nights happening? Just watch this. The Sun is giving light and Earth is rotating on its own axis. And you can see on the side of the Sun, whichever is facing the Sun, okay, only that side you can see the light is there. And the other side, it's a shadow, so you can't see it. So wherever that light is there, that side is day, the other side is night. So that is how days and nights will happen, okay, because of the movement of the Earth's rotation. And you can also see the Earth's rotation from two different angles again. You can see this one actually is Earth rotation seen from outside somewhere, rotating like this, and days and nights happening. The other one you can see that actually if you rotate along with around the Earth and make Earth stationary, think that Earth is stationary, that time actually you can see that shadow moves like that on the Earth, and that is what is the days and nights. This is two views of the Earth, just to get a picture right. Okay. Now, after having developed some kind of a basics on how the movement of the Earth is and how the movement of the Sun is, and knowing planets, and now the question is basically what causes the seasons. So this movement of the Earth, the people say it is going around the Sun, but after Copernicus, the guy Kepler came and said it is not a round, going around in a circle is not the correct approach. It is going on an ellipse. Ellipse is like a egg-shaped circle. Okay, so that triggered imagination of many people. So then what causes seasons? I saw that some people actually are giving me very nice answers. Okay, so look at this answer. It's an interesting answer. Okay, how are seasons caused? That is the question. The answer is that since Earth is in an elliptical orbit around the Sun, it is sometimes nearer and sometimes farther. Elliptical orbit is a egg-shaped orbit. So whenever it is nearer to the Sun, it is summer. Whenever it is farther from the Sun, it is winter. Nice argument. Okay, so let's look at this argument. But the question is, do you agree with this argument? So let us just see whether this is a correct explanation of seasons. Is it because of this that the seasons happen? Because of the elliptical orbit. Okay. So now let us look at the elliptical orbit itself. Earth revolving around the Sun. Okay. Look at this. Now you have, let us say, Earth, the Sun is in the middle, and Earth is there on the elliptical orbit, and it, let us say, goes around like this. So when it goes around the Sun like that, you can see that it is nearest when it is that side, and it is actually farthest when it is that side. So this is far, this is near, so this should be winter, and that is summer. Quite an easy argument. So summer means hot sun. Okay. So nearest is summer, farthest is winter. Is it a good argument? Is this correct? So apparently, let us see whether it is correct or not. Okay. If this is correct, okay, then there must be 2 summers and 2 winters. You know why? The nearest is twice and farthest is twice. So summer, winter in 1 year. Does it happen? So our observation that it is just 1 summer and 1 winter in a year tells us very clearly that this theory of ours wrong theory. Okay, let's dismiss this theory. Okay, this is not how our seasons happen. Okay, so what else can we say? So first we have to understand before going further, this difference between the circle and the ellipse. Okay, this is basically the circle. Okay, circle has 1 radius. Okay, 1 center. And if you look at the ellipse actually has two centers and two radiuses, or two radii, that's what we call. Okay, so we call one of them as semi-major axis, another one as a semi-minor axis, two of them. Okay, and where is the sun? So now, if it were to be basically a circular orbit, we could say sun is at the center. Okay. And if it is an elliptical orbit, where is the sun? There are two centers. Or is it in between those two centers? Where is the sun? Okay. So in reality, sun is actually at one of those centers. Sun is at the one of the centers, not both, not in the middle. It is in one of the centers. Okay. And if you see the distance between that one center and the other side actually is 14.7 crore kilometers, which is like 147 million kilometers. Okay. And if you take the other side from the sun to the other side, which is basically the farther side, there the distance is 15.2 crore kilometers, which is basically 152 million kilometers. That is the farthest. Now it is simpler. How many times it is nearest and how many times it is farthest? Only once nearest, one far. So we could say that our theory may be right if we go this way. Okay. So the nearest one is called perihelion, and this one is called aphelion. Okay, that are the names that they use. Okay. So now, is this theory correct? Is our answer right now? So since it is ellipse, nearest is actually summer and farthest is winter. We could have accepted this theory, provided we actually kind of did not observe one very important information. So look at this information, the next information. The nearest is in January, okay, and the farthest is in July. So if our theory is right, January should be the hot middle summer. Is this true? Is January hot middle summer? No. So something wrong with this theory too. So what could be wrong? So let us see. Okay. So now let us carefully observe how actually the Earth goes around the sun. Earth goes around the sun in a very peculiar way. It rotates around its axis in a very peculiar way. Okay. Now let's look at this Earth. Okay, this is our Earth. Okay, and if you keep the Earth straight like this, okay, and rotate it, this is how Earth rotates. Okay. Now this is called as the axis of rotation. I have just put one tick here, the axis of rotation, around which it rotates. Okay. Now this axis of rotation actually, if it is tilted with respect to the plane of the movement around the sun, let's say it's sun here and it's going around, you carefully watch that animation, it shows very clearly how it is tilted with respect to the plane of the movement. That tilt is supposed to cause the seasons. If you watch carefully, when it comes on the left side, okay, now just keep watching here, when it actually comes towards the left side of the sun here, okay, you can clearly see that the light is lit up like this in this area. Okay. So the top portion, which we call as North Pole and around North Hemisphere is fully lit up very well. It's very near to the sun. Whereas when it is on the other side, bottom portion, the South Hemisphere and this area is lit up well. So what does it tell us? It tells us that there is actually summer. When there is summer on the northern hemisphere, there is winter in southern hemisphere, and there is winter in northern hemisphere, summer in southern hemisphere. In fact, this is true. If you actually go to Australia, there it will be winter when we have summer in the northern hemisphere. So this is the correct explanation. This tilt actually causes the seasons. So if you watch it I stop this and show you the picture. So on the left side here, when it is like this, you can see the light from the sun actually comes straight into the northern hemisphere. Okay, it's a straight hitting light. Whereas here to the Australia, the light is slanted. So it's not very hot. Straight, very hot. Okay. So it's summer when it is this side. When it is the other side, if you look at this, the sun from this side goes and hits it. And this side it is very hot. And this side slant sunlight. And it is winter. Okay. So the winter and summer are not same for northern hemisphere and southern hemisphere. It depends on whether the sun hits slantwise or straight. Okay. Obliquely or straight. And you can even see that the North Pole is always lit up. Even when it is turning like this, North Pole is always lit up. Our South Pole is always lit up. That tells us that it is 6 months of day and 6 months of night in North Pole and South Pole. For all the other places, days and nights are basically happening when it is rotating, not for the North Pole and South Pole. Okay. So now, after having seen that, now you can also see that in the case of if you can watch it, standing on the earth, you can see this actually. If you watch carefully during the day how sun traverses through the sky. Okay, sun actually traverses through the sky in the summer in one way. Okay, in the winter in a slightly more what you call oblique way. Okay, summer and winter they travel very differently. In summer, you see that when it travels, the peak part, okay, the light is coming straight like this, not too much of angle from the top. You can see. During the winter, you can see since it's coming slightly oblique, okay, the light is coming from the side. So when light is coming such an oblique way, naturally it is not very powerful, okay, and hence you see it as winter. The other one is summer. That is the view. So now, do you understand how seasons are caused? Seasons are not caused because of whether the sun is farther from us or not. It is caused because of the tilt of the axis, and that gives the oblique angle. Okay. And hence you get summer and winter. And also, another important point is that when it is summer in northern hemisphere, it is winter in southern hemisphere, and vice versa. Okay. That part please understand. So now let's move on to the second question. So the second question is moon rotating about its axis? Rather, is it at all rotating about its axis? Okay. So I'm asking this question mainly because I have this, somebody told me that the moon that we see is not the entire moon. We only see one side of the moon. We don't see the other side. Okay. And somebody has gone on to the other side and taken a photograph. And you can see here, the moon which you normally see is on your left side. This is very familiar, and day in day out you will see exactly every night we see this kind of a moon. Okay. The other side of the moon looks like that, and we have never seen it. Why so? So from this, can we conclude something? Is it at all moving with respect to its own axis? So I am taking a logic somewhat like this. Okay, I am having this one basic understanding which tells me that from Earth we can only see one side of the moon. So from that I can conclude that moon does not rotate around its axis. If it has rotated around its axis, I would have seen the other side of the moon. So it's not. It is only showing one side. So it is not rotating around its axis. So now with these two statements, am I doing things logically right? I have one input, that is statement 1. And my statement 2 is what I am concluding. Are these two right? So I am just having 4 choices here. So, and let us say whether you can choose the right choice. Okay. The first choice is statement 1 and 2 are true, and 1 actually is the correct explanation of the 2. That's what my basic belief was when I started talking about this. Second one is 1 and 2 may be true, but 1 is not the explanation of the other. Maybe my logic is wrong. Maybe 2 statements are right. So the third one is the statement 1 is true and true is false. So the fourth is both 1 and 2 are false. See, 1 and 2 are false, I can't believe, because I have seen in the data that we are only seeing the one side of the moon. If we are seeing the other side, we would have seen, we always see some moon in only one way. So there is absolutely no difference. It's always exactly same. So it's only one side. So what is the correct answer? Let's just give some consideration on what could be how the rotation and revolution can happen together. Okay. Let's take three cases actually. Moon does not rotate around its axis, but it just goes around the Earth. Okay, that is one kind of a scenario that we can take and see whether it is true. Okay. Second one is moon actually rotates twice around its axis, let us say, before it goes one round around the Earth. Okay, like that means one round around the Earth takes some time. On axis is rotating, but it is rotating slightly more faster, twice around the axis. Why twice? You can take 4 times, 10 times, whatever. I am taking twice just as an example. Okay. And lastly, we will take moon rotating actually around only once around its axis by the time it finishes one round around the sun. So I want to see whether that is a possibility. Okay. So how do we see that? So first of all, moon does not rotate. So now to be able to understand that, what I have done is, there is Earth and there is moon. Okay. And on the moon I have put one dot there. You can see, to show that it is our side. Okay. If that is facing the Earth, that means we are seeing our side of the moon. If the opposite side is facing the Earth, then that means that we are seeing the opposite side of the moon, and our whole assumption gets removed, because we know that we are very sure that we are seeing only one side of the moon. So let's just see what happens when it goes around without rotating itself. So you keep watching here, but when it comes down here, now you are already seeing the other side of the moon. Do you see that? When it is actually going below or on this side, you can see that back side actually you are able to see. Back side of the moon you are seeing there. Okay. So if it doesn't rotate when it goes on the other side of the Earth, okay, definitely you can see the back side of the moon. And since that is not happening, the first theory that it doesn't rotate is wrong. So let's go to the next theory. Moon rotates twice in one orbit around the Earth. So I am going to rotate that moon twice by the time it goes there. So one round on its own axis, one more round on its own by time. So just watch carefully. So this is basically one rotation, the second rotation. Okay. So now even here, when it is rotating, when it finished one rotation, by then we would have actually see the other side of the moon. So since this theory also demands that we see the other side of the moon, this theory is also wrong. So now let us see what is our third theory. So here it rotates around its own axis only once while it rotates around the Earth. Okay. So just keep watching. So this starts going down. So it is rotating around its axis. We are still seeing the front of the moon. We are still seeing the front of the moon. We are still seeing the front of the moon. We are still seeing the front of the moon. Okay. We kept seeing only the front of the moon. So our observation that we are only seeing the front of the moon is basically what is happening here too, which means that this theory seems right. So what is our theory now? Our theory is, by the time it takes one round around the Earth, it also completes one round around its own axis. So moon definitely goes around its own axis, but only once during its entire journey around the Earth. Okay. So how long does it take moon to go around its own axis and to go around the Earth? The answer is 27.3 days. That is the time it takes to go around the Earth, and at the same time that is the time it takes to go around itself. What you see in the picture is actually sun also and the moon also going around the Earth. Okay. So this is the whole complex system that we actually see: sun, moon and Earth. Okay. That brings to the end of the first video, and we will look at the next video with more information on solar system. Thank you. Enjoy the solar system.